Okay. Well, and then I shall start. Somebody asked a question on YouTube about Sam Harris's latest episode. Um, let me just find the question. I think it was just basically any thoughts on that. And I did listen to it when it came out, and the first, I don't want to say half, maybe the first sort of quarter of that, 25% or so, I broadly couldn't agree with them more. They were explaining how ChatGPT works. Of course, they would be able to do that. They're experts in the field, the guests that were there, Stuart and Gary. And there was a debate between them, and the debate was quite good throughout the entire episode, I thought. Audio's clipping. Okay. How about now? Is that any better? Um, All right. That's a problem. Ah, okay. Yeah. So there's some disagreement about whether the audio is working or not. If other people start, okay, good. Yes, maybe it's just a streaming issue. Yeah, and so the first sort of quarter of this episode on making sense with Sam Harris, titled "The Trouble with AI." I'm just looking at it now. Then, being experts, of course, they were able to explain how the current crop of AI stuff works, and I've been investigating this recently, diving into some of the papers, and I agreed with them about their explanation for how it works. Why should there be any dispute about this? Because with complex systems like this, the remarkable thing is that sometimes the programmers themselves don't know how the system achieves the functionality that it does. This has to be one of the first times in the human history of invention that this is a really significant problem. We've built a thing that we don't know how it works. It's as if we were to build an aircraft and not know how it flies, just that it does. Of course, prior to good explanations, it was routine for people to have medicines, native medicines they got out of the forest, and didn't understand how they worked. They didn't understand the mechanism of action. And so now we've built these systems, and there are very poor explanations on the internet. I've been trying to work through not only the papers for things like the transformer paper and various other kinds of AI papers that have been produced recently, but also explainer videos by experts on how these things work. And there is some disagreement sometimes. And sometimes people just say they don't know how it works. But famously, the AlphaGo program, the programmers themselves said, we don't know how it's doing what it's doing. Broad ideas, but not exactly an understanding, not a good explanation, we might say, of how these systems are achieving the functionality that they do. And so, anyway, in the Sam Harris episode, they agreed on that. And so I was, buoyed by the fact that, okay, we have people here who are being sensible. They're not jumping ahead and saying, we understand how this thing works and it's all going to end in a hellscape. Eventually those sort of remarks came, but they were at least grounded in something like a sober admission that people didn't really understand precisely how ChatGPT was achieving what it was doing. We understand the broad idea. The broad idea is that you just have a vast amount of data, and it is trained on this data via a process called forward and backward propagation. And out of that, the ChatGPT system can extract what the pre-existing knowledge is, but it never creates new knowledge. Okay, and that's always my interest is, are these systems creating new knowledge, or are they just extracting out what is already there? This was true, by the way, of the AlphaGo way of programming, and why it was different to previous ways of trying to win at certain games. The chess bots, for example, chess computers, was simply calculating a tree of millions of possible different moves that could be made and figuring out what is the best move out of those millions of moves. The AlphaGo approach was different. It was to look at thousands of games, actual games that have been played, and then to find patterns in the strategies that were being used by the winning players. and then to use those to win against itself. And then it would play against itself and find patterns as to what would beat the best players, what strategies would beat the best players, what patterns are there in how to win, rather than looking thousands of moves ahead. Now, the latest chess engines are also doing this. They're also not only looking millions of moves ahead, but also looking at past chess games. How is this different to what people do, by the way? How is it different to how people learn? People generally, although chess grandmasters and even, not so grandmasters, chess grandmasters will look at previous games to learn something about how to play a good game of chess. This is not how people learn anything, like chess, for example. They don't need to be shown thousands of games in order to understand the rules. They need to be shown a limited number. They're using guess and check, conjecture and refutation. And so ChatGPT is not doing that. That's not the way in which it learns to have a conversation. How does it learn to have a conversation? It is given almost the entire corpus of human knowledge as it exists now. Well, not actually, because we know that GPT-4, that's supposed to be coming out this week, Thursday or something, it is going to be given an even larger number of, a larger amount of data, a much greater repertoire of data, orders of magnitude greater. But still, it is pre-existing knowledge. This is not how people learn. And because it's not how people learn, we shouldn't expect it to be generating new knowledge, to be learning new stuff that's not already in the database, to come up with new explanations. It can give you the pre-existing explanations, but until it's able to give you a good new explanation, as David Deutsch himself tested ChatGPT on, come up with a unification of quantum theory, a successor theory to quantum theory and general relativity, and it was a disappointing result. It couldn't do that. Okay. Then we know that we're not in the presence of something that is intelligent in the way that we should regard things as being intelligent. And what I regard as intelligent, what that word means is, can you conjecture new explanations, good explanations? So that is what I think about the difference between the way in which people learn and the way in which these advanced bots are learning, the advanced AI is learning. Okay, we're not seeing anything like what people do. So we don't have any clue about AGI. There's no sense in which we're closer to AGI. We'll know we're closer to AGI when we understand what it is that people do, what it is that human beings do. Once we understand what human beings do, then we'll be able to program that in silicon or whatever. Okay, that's that. So I did write a couple of notes just as I was thinking about coming on here to do with the Sam Harris stuff. So I said they had a good discussion on probabilistic programming. And then it became authoritarian. Then we had all three, as I suppose I should have expected, converging on how it is that the rest of the audience, more or less, aren't particularly bright people, or perhaps the rest of Sam's audience is bright. But in general, people aren't very bright. And so they need to be led, taught, not be treated as agents themselves who are able to come up with their own explanations, not to have their preferences aren't good preferences. There is a group of wise people that know better than they do, that kind of thing. This came down to the idea of alignment, this whole big issue of how do we get the artificially intelligent systems to align with us? It depends on what you mean by alignment. I've interpreted alignment as being, how do we ensure that these systems share the same morals as us? And there's a sense in which, okay, we want society, other people in our society, to share the same kind of morals as us. Okay. But if that is hard-coded into a system, that's either enslavement on the one hand, okay, because I can't change their mind, or it's a way of ensuring that the system itself is not a general intelligence. Because if it's hard-coded, then it can't possibly make any progress on those morals. Moral knowledge is like any other sort of knowledge in that respect, that it can be improved. and that we should want to improve it. And so we don't want other human beings to be aligned in that sense. Why should we want AGI to be aligned in that sense? Namely, incapable of coming up with a better idea in morality. We don't want that kind of alignment. Anyway, all three of them, of course, Sam and Stuart and Gary, agreed that these systems should be aligned with us. There was a hint at the end there where Sam said, well, you know, these systems, if they're super intelligent, then presumably they'd be also super intelligent when it comes to morality. Okay, and I couldn't agree with him more, but it was a side issue. It skipped over it in passing, but that's the central idea here. I think that is just crucially important to appreciate. That if these things are generally intelligent like us, then they will have the capacity to reason like us and to be moral like us. I don't endorse the idea of superintelligence simply because there's only one way of creating knowledge: guessing and checking. And if we get to a point where a system is able to guess and check at a much faster rate than we can, then there will be ways in which we can guess and check faster as well, by using either narrow AI to help us out with some of the computation required for that, or, you know, Elon Musk is going to come up with the neural implant that's going to speed up whatever the clock speed is of the brain. We're a long way away from that kind of thing anyway. But once we have AGI, I see no reason why we wouldn't also have the capacity to turn ourselves into cyborgs. I was saying recently that we're kind of already cyborgs. You know, here I am wearing glasses. This is a hardware upgrade on the eyes. You know, my Apple Watch here is a hardware upgrade. You know, most people carry their phone with them everywhere. You're part cyborg already. You're part, you know, artificial intelligence anyway. We're kind of artificial general intelligence as it is, as it stands. But their argument was that even YouTube, the algorithm that runs YouTube is not aligned with our interests because it recommends videos that you want. This, according to them, was a misalignment of values. This was not in line with human values. And why? Because if you are presented over and again with the kind of videos that you want to watch when you're on YouTube, this isn't good for you. You become addicted to YouTube and you go down rabbit holes and this kind of thing. In other words, these three intellectuals were telling the rest of us that we don't know what's good for ourselves. That if YouTube recommends a video that we want to watch, we don't know what's good for us. They do. They know what's good for us. If only they had access to the algorithm, they'd be pushing out science documentaries and economic policies that aligned with their political views. Ideas about how to vote and what to think about all sorts of hot button issues of the day. What to think about the AI issue. So this is what their understanding of alignment is. Their understanding of alignment is not that you should generate your morality within certain bounds, the bounds that are generally acceptable by society, but rather alignment means you have to agree with them, including when it comes to what YouTube videos to watch. So their example that the YouTube algorithm constantly recommending to you videos you want to watch, when those videos are the kinds of things that can rot your brain, that kind of stuff, they're too entertaining, too many cat videos, that's bad for you. This is their concept of alignment. So yeah, there was a poverty there of, I would say, reasoning on that issue. And there was one other quote I just wrote down of Sam's. When we have super intelligence, he said, you know, the thing that is 1,000 times more intelligent than us. This leads to a contradiction in what he was saying, but he did say this, quote, when we have super intelligence, the end of our concerns will occur then. The end of our concerns will occur then. What he means is that human beings, because we are 1,000 times less intelligent than this imaginary superintelligence, we won't matter. We won't matter to the system that is 1,000 times more intelligent than us. We will be like ants. Okay, this constant ant thing comes up. It comes up all the time. What is the system going to do when it stands in relation to us as we stand in relation to ants? And as I say, there is no such system possible because we are universal in our capacity to explain. You can't be more universal. There is nothing higher on the hierarchy than us. All you can have is a speed up in processing power and increased memory. We already have the capacity to speed up in many ways using computers, using calculators. We already have increased memory using computers. We already augment ourselves with this stuff. We already think faster and remember more than our ancestors did by many orders of magnitude because of the speed up given to us by technology already. People want to have it directly in our brains. Okay, that's coming too. Okay. But this idea that just because you think faster or you have more memory, or let's concede, come up with explanations at a greater rate, that doesn't mean that system stands in relation to us as we stand in relation to ants. Ants don't come up with explanations at all. At all. We can, in principle, come up with any explanation, and so could the system that can come up with explanations faster than us. So that's that. But also, moreover, adding to this, if you are a super intelligent system, 1,000 times more intelligent than us, your morality will be better as well. You're not going to regard people as ants. You're going to regard them as people, fully fledged, morally valuable, important people that you don't want to wipe out. So it's just, there was contradictions throughout the episode. I agreed with, as I say, the first part, the explainer part was about the transformer and various other kinds of recent contemporary versions of AI and the algorithms and how they work. That was all fine. But they did fall into this, as always, into this rank pessimism. Excuse me while I have a drink, by the way. I'm going to be drinking throughout. Regular viewers of the live stream will know that this is what I do. Let me go to some other questions now. We have quite a few underneath the tweet I put out. David Hearn is just being provocative as always and saying Marmite is greater than Vegemite. And David Hearn being, well, if you're going to be that, you're going to be that provocative, David, of course you would say that. You're British. We know what the British, relationship to cuisine is. So of course you're going to think that Marmite's better than Vegemite. You've got no taste. No, I don't like Marmite at all. I do like Vegemite. What can you say? Australians do have this silly habit at times, of having people who visit our country try out Vegemite, but they always put too much on. It's like a challenge. I don't do that. I want people to enjoy Vegemite. I think Vegemite's good, but it has to be spread sparsely over hot toast with butter. You don't hand it to people by the spoonful. That of course turns them off. But you're wrong. Okay, David, that's a simple refutation. Vegemite is better than Marmite. Joe has asked, have I read Ian McGilchrist? What do I think of his books? I'm afraid I haven't. So again, that's an easy question. I'm sorry, I haven't read his books. Porcell has asked, I'll read out the question. Do you think it will be possible to formalize the concept of a universal explainer in a clean mathematical way, similar to Turing universality? If so, how would you start to formalize intuitive, non-explicit thinking? How different would it be from AlphaGo intuitions? So yes, it must be possible to formalize the concept of a universal explainer in a clean mathematical way, I would say. Because, well, it depends on what you mean by clean and mathematical. It has to be possible to write down an algorithm for what a universal explainer is. Yes, because everything in the physical world is computable. Every single physical system is computable. That's David Deutsch's proof, and that includes us, our brains, what our brains are doing, what our minds are doing. That is a physical process going on there, and so therefore it has to be able to be described by some algorithm, some set of motions of particles or something. Okay, but there has to be a way of describing that mathematically. We're not there yet. We have no clue. How would I start? I wouldn't have any idea. What I would say, however, how different would it be from AlphaGo intuitions? Well, firstly, we have this problem in AI, starting with the term AI, okay? The I, intelligence in AI, isn't at all intelligence. It's got nothing to do with the capacity to generate explanatory knowledge. It's got nothing to do with real creativity. All it is about automating certain things that can be automated. That's what artificial intelligence is at the moment. So we have this problem with language. And so therefore, when we get to things like AlphaGo and its intuitions, there is no such thing as an AlphaGo intuition. What AlphaGo does, the program is pattern matching. And so what they call intuitions is just, this is a particular strategy that was shown to have worked many, many times in winning games. And they call this, kind of intuition. But it's a misapplication of that term, intuition. It's not a real intuition. Yes. But other than that, how would I start to formalize non-explicit thinking? I have no clue. I have no clue. If I did, well, I'd be famous, wouldn't I? Tadas asks, how do you think about inspiration? Is it another form of inexplicit knowledge? Well, yes. All feelings, all emotions result from some kind of knowledge, and in a sense are a kind of knowledge. Why do people become fearful? Well, they have knowledge that the thing in front of them is a threat of some sort. Remember, knowledge is conjectural, so you could be wrong. You wake up in the middle of the night and you think that someone's standing over the top of you, but no, it's just a coat you've left on the coat rack. Okay, but the fear comes from your guess, your knowledge, okay, your explanation that thing is a threat in some way. Now, you're wrong about that. The thing just isn't so. So inspiration is kind of like this. Is it a form of inexplicit knowledge? Yes. How do we become inspired? Well, it's certainly a feeling. It's where you have the thought or something, and then you feel the desire to want to continue doing that thing. At least that's my experience of inspiration. Often it comes from outside, of course. It doesn't have to, but someone will say something or you will see something, and that will prompt a thought, which gives you a specific kind of feeling. And the specific kind of feeling is, now I want to do a thing. In particular, usually it's an intellectual or creative thing of some kind. That's what inspiration is, a certain kind of feeling given knowledge that you have just conjectured about something that's happened, typically from the outside. Okay, but you can be inspired from the inside. Of course, you could be, people talk about shower thoughts, right? You're in the shower and you think of something, then you're inspired to write the poem, construct the blog posts, go and tweet, write an essay, compose the piece of music, whatever it happens to be. When people are, so they're probably the two distinctions that you'd make, is when people are very much isolated and on their own, they can be inspired because they're not being distracted by other thoughts. And on the other hand, when people really are distracted by other stuff, they can be inspired. So they can be inspired in all sorts of ways and places. What I would say is, of course, inspiration generally comes when people are relaxed. That's not the question, of course, but that's how I think about inspiration in general. It is a kind of inexplicit knowledge. I would say that all emotions are a kind of inexplicit knowledge. They're giving you information about your psychology, which may be telling you something about the world. The feeling that you're being watched doesn't come from nowhere. The feeling of fear that some people say they have walking down a street late at night doesn't come from nowhere. You can pick up all sorts of cues and you can't always put it into words. Why do I feel sad about this thing? Why do I feel excited about this thing? Why do I feel fearful about this thing? These various senses that we have, sometimes we can't explain why, but they indicate something that's really going on. one of the reasons that psychology, at its best, exists, to try and get you to put into words what it is. But with inspiration, yes. Moving on, Tanvir Ahmed, maybe for a later episode. There's a Girardian tribe that thinks mimesis is the basis of a lot of things. Would like to see Girard's mimetic theory from Popper's angle. Well, I don't know about this tribe. I know what mimesis is, this sort of knowledge via stories, okay, or stories as the basis of a lot of things. Yeah, okay, well, there's been a lot of cultures like that. I don't know Girard's mimetic theory. Girardian tribe? Yeah, I'm not familiar with this. What would Popper say about that in general, though? This idea that you have knowledge embedded in stories? Yes, absolutely. Of course you can. So the most famous example is, of course, the Bible. Jesus tells stories via parables. There's not moral knowledge in those. There's lots of ways in which we have knowledge embedded in deep wisdom is often embedded in ancient stories. And what would Popper say about that? Yeah, well, it's all conjectural. It's all conjectural knowledge. It could be right. It could be wrong. There's ways of refuting it. These are knowledge claims, which some people know for a while. Sometimes they're not our best idea. But institutions can embed knowledge just as stories can. And you can, so it doesn't have to be, Popper's conception of knowledge is not restricted to purely explicit claims about the physical world, even though it's sometimes cast in that. It's just about what science says. It's about everything. It's about absolutely all kinds of knowledge. All knowledge is conjectural. An attempt to capture something that works might not be true, but it works for you. It may contain truth insofar as it is a claim about the physical world. But again, as we always say, it's not a final truth. Anik has asked, something that Popper said doesn't make sense to me. I do not regard philosophy, this is Popper, quote. I haven't looked this up, so I don't know. I'm taking it on faith that the quote is accurate, that Popper said. It sounds like something Popper would say. Quote, I do not regard philosophy as an attempt to clarify, analyze, or define concepts or words, end quote. And Anik has asked, but isn't defining concepts necessary for better explanations? Okay. So Popper existed in a context. The context is that he often had in his mind, my guess is he often had in his mind the prevailing philosophy of his time. His great opponent, who was Wittgenstein, and Ludwig Wittgenstein was always arguing about the importance or the primacy of language, and in particular, that you needed to define words. And so there's an entire school of philosophy, linguistic philosophy, which is about this, which says that precisely that there's no real philosophical problems. It's just about trying to get your language clear, trying to define terms. And so this is what Popper meant by philosophy is not about that. It's not just about talking about words. Do you need defining concepts? Do you need to define concepts in order to have better explanations? Is that necessary? Depends on what you mean by define. If by define you mean you have to have the meaning of the word set in stone once and for all, otherwise you can't have a good explanation or a better explanation, then no. We can have a very good explanation of particle physics without ever requiring that you define what an electron is. We can admit that there do exist these things called electrons. They've got a negative charge. But we can also admit that there is an infinite amount of complexity even in an electron, that we can continue to understand this thing with ever increased accuracy over time as our theories about particles change. It used to be thought that the electrons were embedded like a bit of fruit in a plum pudding, and that the plum pudding being the atom. And then it became the electron was orbiting the nucleus like a planet orbits the sun. And then it became the quantum vision of the electron as, well, people went through a phase where they really thought it was like waves and particles simultaneously, somehow or other, or depending upon what experiment you did. And now we understand electrons as these things that kind of like particles, but not exactly. classical conception, spread across the multiverse with multiple instances of itself in any one place at a time. And across the multiverse, it more seems like a wave, but in any one single universe, it's more like a particle. We say that these other instances of the electron, uncountably many of them, are fungible instances of the electron. Sometimes, if they're in the same place with the same momentum, but also instances of them with various, okay, or the electron itself can have various values for its momentum and its position simultaneously. So it's this complicated object. As David Deutsch says, it's more like an ink blot, but even then that can be misleading. So do we need to define what electron is, or can we just admit that these things exist? Now, repeat that for absolutely everything ever. Popper says you don't need to define things to solve your problems. You just want to have a deeper understanding. It's not necessary to define things. If people want to define things, in a philosophical debate, let them define the terms. Agree with their definitions and then talk about the substance of the matter. People want to pin down definitions so that they can debate the meaning of the word, but that's not solving a philosophical problem. The most fundamental thing you can say to someone in a philosophical discussion when it's going nowhere is, what problem are you trying to solve? What is your problem? That can be charged, I suppose. What's your problem? But really, that's what, for Popper, it comes down to. It's about problems in philosophy, and we want to try and solve them. How do we continue to make progress? Okay, progress slows down in physics. Okay, what's the problem here? The problem is the slowing of the progress in physics. What do we do about that? Should we more clearly define the meanings of particles? Then maybe we can have this unification of general relativity and quantum theory. If only we can define space-time and what the quarks and leptons are, then we can unify these things. No, of course not. Okay, the problem is we want to figure out a deeper understanding of reality. Is there a quantum of space-time or not? We don't know. Okay, so there are these unsolved problems. So I hope that answers our next question. I sometimes wonder if people are trolling me here. The next question is by Vipin, and Vipin has asked, what is the true definition of creativity? The true definition of creativity. Well, again, there is no true definition of creativity. I don't even really have a definition. I would say that creativity is not like innovation, but they're related. Creativity is the thing you have before an innovation. And innovation is when you come up with something new, and it could be for you, I suppose, but that's the really valuable thing. One product of creativity is innovation. The other product of creativity is abject failure. So we're creating things all the time. We're trying them out in the world. What it means is you've come up for yourself with something new or original. If it works, that's an innovation. You've learned something. If it fails, then it's not. It's still a bit of creativity, but it hasn't achieved anything. So again, what is the true definition of creativity? I would just say the capacity to generate something original. But that's circular. Then you'll say to me, well, what does the word generate mean? Well, it means create. Okay, there is no getting away from this problem when people demand definitions of circularity. Okay, or just assertion, mere assertion. Either you're going to simply assert something, or you're going to be led into an infinite regress. Okay, I define creativity in terms of generation. Generation is defined as what? Coming up with something new. What does coming up with something new mean? Well, it means a creation. It means something original. All these words kind of mean the same thing. So you can't get to the bottom, as it were, of what any word means. All you can do is just have an understanding of it, a conjectural understanding rather than a definition. Roshan Ali asks, can you speak about the fine-tuning of the universe? that section in BOI confuses me. Specifically, why does it need to be explained, even if variations of constants still permit life? So I would urge you, Roshan, to go to my fine-tuning episode then, discussing that section of the beginning of infinity. That's why I made those videos. I made those videos specifically so if anyone is in the position where, well, no, I specifically made the videos so that I would understand the chapters better. That was the first and primary reason. The second reason, which is a happy benefit, is that other people find these things useful. And so I have explained the creation chapter, chapter 4 of the beginning of infinity, in my video series in 2 parts, one of which is called fine-tuning, one which is all about devoted entirely to fine-tuning. All of that said, because I can't obviously recapitulate that approximately hour-long episode here right now, let me answer the question. Variations of the constants of nature would allow life to continue. That's true. So, for example, let me try and remember the numbers here. Is it the charge on an electron is 1.602 times 10 to the power of minus 19 coulombs, I think. And that is the same as the charge on the proton. Okay, so that's the electrical charge on these things. Of course, the electron is negative and the proton is positive. Okay, it has a specific charge. And so that charge tells you how strongly electrons are going to repel one another. And so that has consequences for atomic bonding, which is all about, electrons repelling each other and ions, positively charged atoms, loosely speaking, attracting and bonding, atoms bonding together. So if you change the charge on an electron by a fraction of a percent, let's say 1/10,000th of what it is, then chemistry will change a bit, but you'd still be able to have life. Life would still arise. But if you doubled the charge on an electron, this wouldn't be the case. Atoms would repel one another. They wouldn't be able to bond. Carbon is not going to bond with itself in the same way that it does. So this is one example. A better example is, of course, the value of gravity. G equals whatever it is. Okay, the universal gravitational constant set throughout the universe determines the strength of gravity throughout the universe. And it appears in Newton's theory of gravity. This letter G has a particular value depending upon what units you use, and it appears in Einstein's general relativity. It sets the strength of gravity. If the value of G was much greater than what it is, I can't remember exactly the amount by which you'd need to change it, but let's say you changed it by 10%, increased. You increase G, the value of gravity, this gravitational constant, by 10%, then all balls of gas that would otherwise form into stars would collapse into black holes, all of them, which means you'd have a universe of nothing but black holes. Boring universe, a universe without life, without planets. And so therefore we wouldn't be here to ask the question about why G has the value that it does. On the other hand, if you made G 10% less than what it is, gravity would be 10% weaker, and balls of gas that would otherwise collapse into stars would merely heat up, expand without fusion ever beginning. I'm not sure it's exactly 10%. You can look these numbers up. But this is the idea, right? This is the idea. Now, it's finely tuned because you can't have a huge range of G, the value for the gravitational constant, without one of these two things happening. Either everything collapsing into black holes or no stars forming at all. This is the fine tuning of G. Now, repeat that for absolutely every single constant: the charge on the electron, the speed of light, the rate at which the universe is expanding, the fine structure constant, which has something to do with these things as well. There are many, many constants. There is a cosmologist who's on Twitter, Luke Barnes, Australian. Now, not only because he's Australian, but also because I would regard him as just about the world's leading expert on this question of fine tuning. His blog is absolutely amazing. He's an academic at the University of Western Sydney. He wrote a book with Geraint Lewis from the University of Sydney called A Fortunate Universe, all about this stuff, okay? How the constants, if you change any of them by a little bit, you won't get life. Some variation, like as Roshan, some of them variations still permit life, but not all. And this is the point. This is why fine tuning is a problem. We don't understand why the values of the constants are the way they are. The two solutions that are usually put up are either, well, the dials have been fixed for all these constants so precisely that someone has done that, something or someone, normally given a particular name that we all know, God. Okay, God has designed the universe in such a way. The other alternative is, and this is the Max Tegmark idea, but it's not only him, and lots of people say this, that, well, all the possible values of the constants are out there somewhere. We just happen to occupy one of the universes, multiverses, where the constants are what they are, and so here we are. It shouldn't be surprising. That's a bad explanation in David Deutsch's terminology, because it explains absolutely anything at all. Now, the other issue is that changing the constants is one thing, changing the value of these physical constants. The speed of light appears in certain equations. The charge on an electron appears in certain equations. Planck's constant appears in certain equations. G appears in certain equations. Okay, well, that's one issue. They appear in the form of the physical laws, the mathematical form of the physical laws. But the mathematical form of the physical laws could also be changed if you have this multiverse of multiverses, normally called the plenitude. Okay? The plenitude is the set of all universes with every logically possible set of physical laws. And logically possible doesn't have to mean conceivable, because perhaps we are limited by our brains in this universe and what they're physically capable of doing. If there are aliens in universes that obey different physical laws, then those aliens will have brains obeying different physical laws, so they can probably imagine different things to us, because their brains are operating via a different set of computational laws than what our brains are. So they can compute different things. The things they can prove are different. The mathematical things they can prove are different. They can imagine different things. So the logically the logically possible set of universes, if they existed in physical reality, in some way, they had some physical reality to them, lots of those would have, people in them as well. But the overwhelming majority wouldn't. Okay, but anyway, Luke Barnes is the guy on Twitter anyway, as well as on Closer to Truth, where he discusses this stuff. Paul Davies discusses this stuff. What David says there is that the more constants you put together, the more remarkable this fine-tuning thing happens to be. But you can't measure universes, is the important thing. The way in which you count universes to say that this proportion of universes is friendly to life, and this proportion of universes wouldn't be friendly to life, that's not easily mathematically countable. The way in which you order these things, I won't go into that now. That's back, in my video about all of this stuff. And I think if you just type in my name, Brett Hall fine tuning, into Google, you should get at least one or two articles on my website specifically about this stuff as well. And I've written long pieces about this. Anton Schmitz has asked, how can we apply Popperian epistemology to organizations or companies? Can we use its lessons to create better organizational knowledge? Yes, I'm not an expert in this, but there's only one way to create knowledge. There's only one way to improve things, which is via conjecture and refutation. And so what I would say is organizations or companies need to avoid doing the thing that has traditionally been done, which is an authoritarian top-down approach, where the higher your rank as supervisor, manager, senior manager, CEO, chairman, whatever, chairperson, that system should not be regarded as a system of competence. It should be regarded as a system instead of particular skill. So the CEO has a particular skill about how to do their job. but shouldn't be expected to know how to do anyone else in the company's job, unless perhaps they've held that job at some point. But even then, things can change. And so that's what I mean by it's not a hierarchy of competence. The CEO isn't the person who is most competent in the entire company, but rather the CEO is the person who should be the most competent at performing that role in the company. That would be the Popperian view. But the traditional view is, of course, well, they're the boss, so they will tell you how to do your job. Okay, I'm sure many companies are not like this, by the way. I don't hear of, well, I do hear of companies where managers, by virtue of the fact that they're the manager, think they know how to do the job better than the person that they're managing. But what they should be is a good manager. They shouldn't be the best person at doing that other role. They should be good at managing people. Okay, so this is what I would say about Popperian epistemology, because it allows recognizes that every single person is a creative entity who can learn and develop expertise in their particular role to the point where they become the most competent person. Obviously, when they're training, this isn't true. Obviously, when they're training. But modulo that, assume everyone has been in the company for 5 years, occupying their present roles for the last 5 years. Okay, that's unlikely. If that is the case, then everyone would be the most competent person in that role. The CEO is not going to know better than the team leader how to lead a team, that small team anyway. And the team leader is not going to know better how to do that specific job that the person is doing. That's what Popperian epistemology would say, which stands in stark contrast to the authoritarian modes where the manager is walking around on the floor, like a teacher, telling people what to do, micromanaging. This whole concept of micromanaging. That's where that would come from. I suppose we would say Popperian epistemology, as applied to a company, is the perfect refutation of micromanaging, because micromanaging is authoritarianism. It is saying, by virtue of my position, my rank in the hierarchy, I know better than you. Not because I have a better explanation, but because I have greater authority. Okay. In the distant future, all companies can be collaborations where the CEO technically isn't more highly ranked than everyone else, but rather has a specific role, which is that set of tasks that the CEO does. All right. Anyway, Thibault asks, why is the reach of a good explanation determined by how hard to vary it is? It's not. It's not. Oh, he's giving me a reference. Referring to pages 28 to 29 of BOI. Okay. I'm going to check that in a minute, Thibault. And would you consider doing a new Topcast episodes on a chapter already covered, like chapter 1 of BOI? Oh, yeah. Well, I've thought about that before. Yes. Yes. I don't disagree with anything I said. I think the substance of what I say in my very first episode on the beginning of Infinity holds true. I've listened to it recently because I've been making these shorts episodes and putting them up on YouTube and on Twitter. So I doubt I could improve. Sounds terrible, but I doubt I could improve on the substance of what I said. But I can certainly improve on the presentation. I was halting, more shy, reticent to be more confident, I suppose, on camera than I am now. And so that would be a change I would make. So I would re-record or perhaps re-explain chapter 1 just for those reasons, for matters of style, I suppose, more than anything else. But otherwise, I think that, what that first episode, it's not first, one of the first episodes of Topcast, and those first few episodes of Topcast, I think they still stand the test of time in the sense that I don't think anything I say there would be phrased differently. I don't think that I would necessarily be able to improve my explanations, but the presentation or the tone might be different, I suppose. I could be possibly more engaging. Okay. But okay, well, let's go to Thibault's challenge. I'm regarding it as a challenge. He says, why is the reach of a good explanation determined by how hard it is to vary? How hard to vary it is? Before I go there, I'm just going to say the reach of a good explanation has nothing to do with how hard to vary it is. Because a good explanation is hard to vary. But I can have a good explanation of where my cat is right now. I can have a good explanation of where my cat is. Okay. It happens to be in the other room right now. I know that because I saw it walk in there. Now, and the doors are closed, so it has no other options. But that has no reach. That has no reach, that explanation. Reach means it applies elsewhere. Some explanations have reach. Some good explanations have reach. In particular, physics explanations have reach. Chemistry explanations have reach. Science explanations in general have reach. When Newton came up with the universal law of gravitation, that's a good explanation. It's hard to vary, and it has reach. In what sense does it have reach? It reaches out from his desk where he wrote it down to Mars, the Andromeda Galaxy, and everywhere throughout the universe. That's reach. It reaches into those places to govern what's going on there as well. The same is true of chemistry explanations, biology explanations. Certainly, evolution by natural selection reaches throughout the universe. We expect that there's only one way that life can arise and gain diversity, which is random mutations and then selections. Okay. Until you have intelligent design like we can do. But let's go to, okay, the challenges there, pages 28 to 29 of the beginning of infinity. So let me look this up. I'll just bring it up on my Kindle here and now. I could be wrong, I'm always. So 28 and 20, 1 second, and I'm mumbling to myself. Okay, page 28. Okay, so it begins on page 27, actually, where David first mentions reach. He's talking about the seasons explanation, the axis tilt explanation for seasons on Earth, and is basically saying, look, once that seasons explanation had been explained as applying to one hemisphere, it reached around to the other hemisphere. It applied there, but not only there, it also applied to any other planet which was tilted on its axis. Any other planet that was tilted on its axis, therefore, would have seasons as it orbited the sun. David says, quote, "This reach of explanations is another meaning of the beginning of infinity. It is the ability of some of them to solve problems beyond those that they were created to solve." That's the meaning of the reach of explanations. Not determined by how hard to vary it is. That's a separate issue. Let's skip and find where he talks about hard to vary. He goes on to say, the reach of an explanation is not a principle of induction. It is not something that the creator of the explanation can use to obtain or justify. It is not part of the creative process at all. We find out about it only after we have the explanation, sometimes long after. It has nothing to do with extrapolation or induction or with deriving a theory in any other alleged way. It is exactly the other way around. The reason that the explanation of the seasons reaches far outside the experience of the creators is precisely that it does not have to be extrapolated. Yeah, it's a universal theory. It's like Einstein's general relativity just applies everywhere for all times, not only at all points in space throughout the universe, but at all times in the past and in the future. That's the universality. It doesn't need to be extrapolated. There's nothing here, I'm afraid, Tybalt, about hard to vary. So no, rather than linger on this any longer, yeah, I'm afraid the answer to your question is, why is the reach of a good explanation determined by how hard it is by how hard to vary it is it isn't. The reach of a good explanation is determined by what it is explaining. If it is explaining a phenomena that exists throughout the universe, then it applies throughout the universe. But if it's explaining the phenomena of the location of the cat in my apartment, it applies to my cat and to no other cats. It's not a universal claim. It has zero reach. It doesn't go beyond my apartment or my cat. So, yes, reach is a property of a specific category of explanations. Those explanations that apply to multiple entities. Okay, you might have an explanation of Tesla cars that doesn't apply throughout the universe, but applies to Tesla cars. Okay, for example. So it has some reach, but not universal reach necessarily. Tybalt goes on to ask other questions. Are there any other theories that could be good candidates to be added to the fabric of reality? Or even if they wouldn't fit, what do you consider as good explanations worth exploring? Well, constructor theory these days, of course, would possibly be added there. But there's a question about whether, in David's terminology, he would even admit that it counts as a good explanation at this point. A conjecture, although it is revealing, it's making progress. It's making progress. But David's always very modest about these things. Perhaps he would include that now. It's been some 25, well, coming up to 30 years. No, yes. It's been a long while since the fabric of reality now. So, yeah, there's that, I suppose. Look, people have said, what about economics? Could economics be added there? Could you have or political systems? But I think those are consequences of just the right epistemology. Epistemology is the main thing. How do you generate knowledge? Okay, so why wouldn't you put an economic theory in there? Well, because economic theory is about how to create wealth. Wealth is just a kind of knowledge about how to achieve certain transformations, the repertoire of transformations you can make. So the way to generate wealth which is an economic theory, is logically entailed by how to generate knowledge, which is epistemology. And for similar reasons, all other, things like that, like political theories, they would come into that as well. How to create the knowledge of how to keep a society resilient and that kind of thing. Well, that comes out of epistemology. But, I'm sure that you could put in, more chapters. Maybe David had more chapters and he just pared it down to 4. I don't know. But broadly speaking, I don't have any suggestions for other theories that could be good candidates to be added, apart from what I've just said. But there's an argument for many of those things being subsumed. It's like the best case I've heard is, Naval asked, why isn't relativity in there? And the reason relativity isn't in there is because David explicitly says that he regards quantum theory as the deeper of the two theories, quantum theory versus relativity. And so, maybe one day we will have a space-time geometry of the multiverse or something like that, a geometry of the multiverse, which would be, or a quantum, the theory of quantum gravitational computing, which would be the theory that you could put into the fabric of reality of next century, let's say. But we're not there yet. So that would be my answer to that. Tybalt, another question, what is the role, if any, of rules of thumb in understanding the world? Yeah, well, in understanding the world, a rule of thumb is just a pragmatic way of taking action when perhaps you don't have a good explanation. Just do this thing, often called a heuristic. I don't always have a good explanation for precisely the way in which I make my tea. An explicit explanation, I just have rules of thumb. I think many of us have rules of thumb throughout our life in order to make things more efficient. You don't always need to have a highly coherent, highly explicit, good explanation of everything you do throughout the day in your personal life. you just go by rules of thumb. Okay. It's about time I had a haircut. I don't have a good explanation about precisely the length that I need to have my haircut at. It's just it's a feeling. It's inexplicit. Rule of thumb is about every, once a month, something like that. So I don't know about understanding the world, what the role of rules of thumb are, except you always in science, there comes a point at which you reach the inexplicit. And the great physicists will talk about their intuitions, that this thing feels right, and so they do this particular thing. So they have rules of thumb. Anyone does mathematics realizes there are rules of thumb there, and you develop an intuition for being able to get to the solution of a particular problem, let's say. All right, so that appears to me to be Twitter stuff. I'll just double check nothing new has come along. Chu Pin Huan has asked, can you discuss how much is the research field of economics as a social science adhering to the Popperian conjecture and refutation practice? My answer to that is I don't know. The research field of economics, I'm not sure. All I know is that whenever I look at economics, and I think I talked about this in one of the other live streams, what I find with economics is that rather a lot of it, okay, let's put Austrian economics aside, is about the role that government should have in the economic system. What interest rates should be, how they should intervene to set prices on this or that. And so that becomes economics. So I don't know. There's also a problem here of you don't want your economic policy to require testing in the same sense as a scientific theory requires testing. Because if you start testing various economic theories, you run the real risk of causing huge suffering. It's the same kind of idea because economics and the intersection of economics and morality is large. You don't want to have to test your moral theories to find out which one causes more suffering. This is why we have principles we can come to understand, or ideals, as I say. Our understanding of any moral principle or ideal is imperfect. All we have access to is an imperfect understanding of things like don't destroy the means of error correction, let's say. That can be our ideal. It doesn't have to be an unalterable foundation. What it can be is our best understanding of how to ensure progress continues over time. Okay. You don't need to test that out there in the real world. It just is. It's a claim that you can make which doesn't need to be falsifiable. The same as, all humans are created equal. Yeah, all humans are born equal. I think we all have the same moral worth. That doesn't need to be tested. That's just a thing that you take as a premise, and perhaps we can understand it better over time, but that's our understanding of it now is our understanding of it now. I would regard economic principles as kind of like that. So you don't need to try and test them in the real world. What you say is, well, what I say is if you want to maximize wealth creation, which is what the domain of economics ostensibly is about how wealth moves throughout a society, and that's called the economy. And it includes money and goods and trade and all that sort of stuff. The free exchange of the creativity of people one with another. A basic principle of which I would say is that if you've got a service and I require your service, then we should be free to exchange your service for my money, my value for your value. And a third party doesn't have any interest in that. There's our principle. Now, of course, we live in a society where the third party does. Everyone else in society apparently does have a claim on that via the government, via the taxation system. Okay, so there we have a difference in principles. But let's say you agree that only one other party has a claim on the transaction. So there can be 3 people, 3 entities rather, you offering the service, me wanting to purchase your services, and the government, but no one else. You know, but then of course, you know, so therefore the mafia is not a legitimate, you know, party to come along and say, well, now you've got to pay us protection money, which is what some people regard, you know, parts of the government as. Okay, I'm neither an anarcho-capitalist nor a socialist. So I occupy this position of minimal government and think the institutions are very important. But at the same time, I think we should be incrementally moving towards smaller government, because at the moment the government is rather large and taxes rather highly. And all signs are that progress, knowledge creation, and optimism would be much greater. Things could occur better and be better for everyone if we just reduced, you know, certain regulations and taxes and that kind of thing. None of that is to say that the institutions of government are unimportant. I could make a case that they are very important, but sometimes there's overreach. All right. So now let me go to the YouTube questions, of which there are only a few. John Ortiz asks, I want to know more about constructor theory. What prerequisite should I know? The first person to get in contact with is Logan Chipkin. And on Twitter, he is Chipkin Logan. I follow him, so if you just look at my followers, you'll see him among those. And he's a great promoter of constructor theory. The first thing to do is to watch David's YouTube, you know, expositions of constructor theory. Chiara Marletto's. I would buy The Science of Can and Can't. Watch my videos. They're now complete. I just need to talk to Chiara herself, interview Chiara about that. So if you want to know constructor theory, The Science of Can and Can't, the book by Chiara, perhaps watch my videos. Watch David's, for want of another term, lectures, presentations on constructor theory, Chiara's stuff on constructor theory, and look up Chipkin, Logan Chipkin, who is a great expositor of these ideas as well, and has interviewed David and Chiara about this. So yes, worth getting into his stuff. Adil Zishan has asked, would you explain the naturalistic fallacy, why it's wrong, and any of its common manifestations in science or philosophy? Thanks. So the naturalistic fallacy is, if a thing is natural, then it's good. Healthy living people are like this. You know, you should eat raw food because raw food is natural. And if you cook things, that might burn them, and that can cause cancer. And cooking is not natural, but eating raw stuff is. I don't know what they think about funnel web spider venom or snake venom. That's natural. What do you say about that? What do you say about chemotherapy? That's unnatural. So the naturalistic fallacy is, just because a thing is natural, it has arisen via evolution by natural selection, that therefore it is virtuous in some way. So it's completely false. Common manifestations in science or philosophy. I can't think of anything off the top of my head. You know, perhaps in morality, you know, people talk about, well, look at the altruism that exists in monkeys and primates and stuff. Altruism is good, isn't it? Yaron Brook is great on altruism. I watched an episode of his recently, one of his clips from YouTube, where he was talking about Mr. Beast. Mr. Beast is the biggest YouTuber of all YouTubers. You know, multi-millionaire, you know, I think he's worth $50 million or something just for making YouTube videos. And Mr. Beast gives away a lot of stuff. He gives away money, he gives away cars. He was in the news. There was controversy about him because he helped 1,000 blind people, I think it was 1,000, regain their sight, and people were criticizing him Why would you criticize that? They were saying he was just doing it for the clicks. He was just doing it for, social media kudos. Even if he was, who cares? Why is that a reason to criticize him? But Yaron Brook was making the point that, this is not altruism on his part. Altruism is a bad thing. Altruism is where you give away stuff for no gain, purportedly no gain. The more it hurts you, the better it is. It's the Christian idea of giving alms. You should expect nothing in return. Nothing. Jesus was the great altruist where he gave up his life for everyone else. And this is supposed to be the pinnacle of what a person does. Expect nothing in return. Just work for others, not for yourself. And Ayn Rand's idea is, of course, the opposite to that. Work for yourself. And by doing that, you actually help other people far more. So when Mr. Beast gives away stuff, which is charity, Yaron Brook's point was, well, he was saying, you can't say this is altruism, because, he might be getting the clicks and he might be getting kudos and he's getting all sorts of stuff himself returned to him. That doesn't make it bad. But we exist in a culture of altruism where you're supposed to be altruistic. And if you do get anything in return, if you make a profit by being nice to people, by curing blindness, let's say, then it is somehow diminished by the fact that you got something in return for that. Kudos, publicity, more followers, something like that. But that is a hang-up of Christianity. Christianity has virtue in it, but this is not one of the virtues. There's nothing wrong with doing something and getting something in return. There's nothing wrong with profit. The profit motive leads to a much better world. If everyone was giving up their time for free, the world would grind to a halt. The world cannot run on altruism. So the naturalistic fallacy here is, even if it was true that gibbons and chimpanzees were altruistic, and I doubt they are, that wouldn't make it good. So that's that's the naturalistic fallacy. Max Lanning has asked. If anyone else has a question, feel free to ask. Max has asked, could David Deutsch's theory of explanations be a unification of theory of knowledge, evolution, and computation? Yes, it is. Yeah. His idea of hard to vary explanations as the thing that we are sort of focused on, the thing that leads to progress in society and civilization, the very thing that underpins why it is we make rapid progress, coupled with this culture of criticism. But this search, the culture of criticism exists because we have this search for better and better explanations to improve our lot. That is the theory of knowledge. And the theory of knowledge also explains evolution. Now, it's not explanatory knowledge now, but it is a kind of hard to vary knowledge, okay? Biological knowledge, the knowledge in your genome. Change it a little bit, and you've got a tumor, generally speaking. Organisms are hard to vary. You vary them, they tend to go extinct, okay? Or vary the genome for any given individual, and it tends to die. Okay, so this is a hard to vary thing. Computation is sort of related to this because, well, every physical system is computable. All knowledge creation systems, which are people, at the moment, human beings, and the knowledge that is in evolution by natural selection, in organisms by evolution by natural selection, these amount to kinds of computation. So this is the way in which it's unified. So all systems that generate knowledge are computing stuff in a sense. It's a kind of computation that's going on. And it's a method of error correction, which is also what digital computing is fundamentally about. Okay. Adil has asked, could you explain what Popper meant by the pragmatic problem of induction? Well, it's the same as the regular problem of induction. This idea that, well, you need to try and explain how it is that you get to a particular theory. There's What we're after are explanations. We're not after generalizations of observations. The problem was that the greatest success was had by Euclid in ancient Greece. Euclid laid down the laws of geometry, the rules of geometry, and wow, how amazing they were, how successful they were at enabling people to do things that they hadn't been able to do before. Make predictions and derive knowledge, and it was pristine and beautiful, and it seemed to be certain. You could prove things using Euclid's elements, using that first, these early attempts at mathematics. Now science comes along and it can't quite prove stuff, but it's got explanations. But there's a problem for the philosophers. How can we know that what is claimed in science is certainly true? Over there in mathematics, you've got c squared equals a squared plus b squared, Pythagoras' theorem. It's certainly true. We've got many, many proofs that this thing is absolutely, certainly true. Can't deny it. Start with your axioms and get to this theorem. Also, what do we do in science? Well, people say, well, maybe it works via not deduction, as that is, can deduce that c squared equals a squared plus b squared, given some axioms of the geometry. Maybe we can't quite do that deduction. We've got the next best thing, induction. Assume that the thing just continues. You see all these white swans. Every swan you've seen so far is white, so you presume all the swans you will see in the future will be white. That the sun has risen every single day of your life. Sometimes it's hidden by clouds, but you presume that you're going to see the sun rise again tomorrow and every other day. Induction. Can't be sure, can't prove it, but hey, better than nothing. Well, what's wrong with this? Well, you're not getting explanatory theories is the first thing to say via that route. Nothing about claiming that every single swan is white tells you anything about the explanation of birds. That's not an explanation. All you're doing is saying what color swans are. That's not science. How is that science? You can't write a peer-reviewed journal paper on that. The sun rising every day in the past is not a cosmological theory. It doesn't tell you about the motion of planets. It doesn't say why. And you don't get why from just repeatedly observing the sun. What actually happened was people looked in the sky and noticed that all the stars at night moved in the same way, except for these wandering stars, planetos, okay, Greek word that led us to the word planet, which meant the things that wandered across the sky. They didn't fit with the regular pattern. That was a problem that required a solution. The solution was an explanation. And the first thing was not repeatedly observing that. It was Ptolemy writing down, well, maybe the Earth's at the center. We've got this geocentric view, and then we're going to have these things called epicycles. The sun goes around the Earth, and then planets go around the Earth as well, but then they orbit on their orbits, and this is called the epicycle. You can look this up. So this grand explanation didn't have anything to do with deriving that theory from looking at the planets. He didn't get the epicycles by looking. It came from here onto the paper. He wrote down and drew pictures. Now, it was wrong, refuted eventually, conclusively, by Galileo. Galileo, who pointed a telescope at two places, importantly. One, Venus, where he could see that Venus had phases. That couldn't be explained by the Ptolemaic view. Could only be explained if the sun was the center of the solar system and Venus went around the sun closer than what the Earth did. That would explain the phases of Venus. And not everything went around the Earth, because he pointed his telescope in the other direction out to Jupiter and saw that there were Galilean moons. There were 4 moons that he could see going around Jupiter. So not everything went around there. So he had the explanation of heliocentrism, the idea that the sun was at the center. Now, Copernicus was there before him, but he had the crucial test, the experiment, by observing these celestial objects and distinguishing between these two theories, the Ptolemaic view versus the heliocentric view, the geocentric versus the heliocentric. No point in that story that I just gave you are you generalizing from observations. It comes from his mind, his conjectures. There's no repeated observations here. It just never happens. Einstein was interested in problems to do with electrodynamics, also happened to solve problems about the way in which Mercury didn't quite, fit its orbit as it went around the sun, as predicted by Newton. Comes up with general relativity. Again, not observing things over and over again. The idea of induction is that you need to have some justification for this set of observations going on off into the infinite future, extrapolating. But you can only extrapolate. I was saying this on Twitter today. You can only extrapolate if you already have a theory. If you see something like the sun has risen every day in the past, then you need a theory. Extrapolating and saying it will rise again tomorrow can only legitimately be made if you already have a theory about why it should. Otherwise, there's no reason to think that it should. You're just saying that, the past resembles the future, but the past doesn't always resemble the future at all. If every day in the past for the last 5 years, you have measured the temperature of water from room temperature up to 80 degrees Celsius, you will find a perfect straight line if you've got a constant heat source. This is, my article on induction talks about this. Brett Hall induction, Google it, you find this. It's a standard experiment anyone can do. You put a pot of water on the stove, turn the stove on, put a thermometer in, have a stopwatch, plot the time and the temperature every minute, and you'll see it goes up steadily. Beautiful straight line. Stop the stopwatch stop the stopwatch when you get to 80 degrees Celsius. Just stop it there. You'll have this beautiful straight line, lovely straight line. You can do that for years, every day, repeating the same experiment, noticing that you're always getting this straight line thing. So that's the past set of observations. Should you do that experiment again tomorrow, you get the same thing? What if you decide to boil the water? What happens? Well, I used to do this with students. You get them to extrapolate. You get them to do it to 80 degrees, 90 degrees. Say now, okay, turn the heat off, turn your Bunsen burner off. Now, let's guess what happens. Guess what happens. They all draw a straight line. They all draw it. They just connect the dots and they extrapolate. They don't know about what's called latent heat. They don't know that once you get to 100 degrees Celsius, you get a plateau. That the water boils at 100 degrees Celsius. That the temperature does not continue to increase. All induction is like that mistake of extrapolation. If you think that you can extrapolate that line, you must have a theory first to legitimately extrapolate. Otherwise, you've got no reason. There's no reason to prefer that straight line to anything else. In particular, because in the case of water or any other substance, it plateaus. So there was no legitimate reason for extrapolating the straight line. So why should you think in any other situation you're entitled to extrapolate without first having a theory? If you came along and you said, like, if someone said to me, I've got this substance here, unknown, it's a liquid. If we heat the thing, okay, over time, I want you to predict what the shape of the heating curve will be like. I would draw something similar to water. I wouldn't know exactly when it's going to boil, but I would tell you that, well, I have a theory, I have an explanation from chemistry that all liquids eventually turn to gases if you give them enough energy because they're made of particles and the particles are bonded together quite strongly when they're a liquid. But eventually, if you give them enough energy, they'll achieve effectively escape velocity and turn into a gas. And at that point, at that moment of boiling, what happens is the temperature plateaus. The temperature remains the same at the boiling point, at the boiling temperature. That comes from a good explanation. Siri's telling me. That's the explanation. So all induction was a desperate attempt by people who didn't understand knowledge to justify scientific knowledge, but they didn't need to. As Popper explained, you didn't need this. There is no problem of induction. There is no requirement to fix induction, to figure out how it is that we justify claims in science as true. Instead, we have explanations of stuff or we don't. And when we do, that's the explanation. There are no competitors. And if there is a competitor in science, then we do a crucial test, an experiment, to rule out one of them by cleverly designing the experiment that will go one way if this theory is correct, and another way if this theory is correct. Or better to say, if this theory is wrong, it will go one way. If this theory is wrong, it will go the other way. Correct is ambiguous there. By correct, I mean best explanation for now, of course. Excuse me. Dale Bolender has suggested for an excellent grounding in economics, read Human Action by Ludwig von Mises. Yes, I've read Mises. Great, fantastic, yeah. Economics is just one of those areas. You know, I'm interested in it to a limited extent. It's like morality. It's just one of those things where people have grand theories of morality. It's like, are you a utilitarian? Are you into virtue ethics, whatever? It's just one of those areas where, you know, I'm libertarian with morality. It's like, just if people aren't being hurt by you and your actions, then they need be left alone. The same is true in economics. If this transaction is not affecting you, leave it alone. Leave them alone. Leave those people involved in that transaction alone. So I think that economics is kind of leave it to the people who are interested in it. But I think the more pressing issue when it comes to economics is to try and get the government out of the economy as much as possible. At the moment, not only in the places like China, where you have severe government control of the economy, the Western world is plagued by government interventions into the economy. And it shouldn't be that way. So that's my central interest when it comes to the economy, is how to fix the problems inherent in it with vis-a-vis government involvement. Adil, what is the difference between a research program and a theory, e.g. natural selection? What implications does that have for testability, falsifiability? Okay, so a research program is a broader category of things than a scientific theory. This is why, you know, people talk about evolution by natural selection as being a research program. It's a claim about how the diversity of organisms arose, or what we would say these days is how biological knowledge arises. There's no observation that you could make that would refute it. You can't find an organism that would refute evolution by natural selection. So people say, oh, it's untestable. Who was it? Peter Medawar said, well, if you found, was it him? Someone who said, well, if you found rabbits in the Precambrian, this would refute evolution by natural selection. In other words, the Precambrian was a time when you didn't have complex organisms. It's in the fossil record. If you found rabbits in that strata, then that would refute evolution by natural selection, but it wouldn't. It would just mean you've got a problem, and the problem might be solved by, well, rabbits just evolved much earlier than you thought, or more than likely, you've made an error with your rock strata. Okay, so rabbits in the Precambrian do not refute evolution by natural selection. No observation seemingly would, unless, I think David says this, unless you had just repeated, highly unlikely coincidences where favorable mutations are only ever occurring. That would cry out for an explanation. If there were only favorable mutations, you know, mutations are normally bad. If you had an organism where it was just constantly good, constantly getting better, rapidly getting better, mutations that happen don't cause cancer, don't cause any problem. They're always in the direction of, well, now the organism has legs, now it has wheels, now it has wings, now it has rocket engines. There's evolution by natural selection. Then you've got a problem. then you might have refuted evolution by natural selection. There's something else going on there. But that's not the situation we're in. So we call this a research program because there is no such experiment that you can do. Instead, there are theories within biology, but the framework is evolution by natural selection research program. Constructor theory might be kind of like that as well. But not all good ideas, as I was saying earlier, need to be testable or falsifiable in the experimental sense. Theories of economics, theories of morality, even certain sociological, psychological theories don't need to necessarily be testable, falsifiable. It's specifically within science that you need to have testability. Okay, but if you claim to me that you prefer chocolate over strawberry, that's a psychological theory that you have. I don't need to be able to test that. I don't have any way of testing that at the moment. It's not testable from my perspective, third person. So yeah, but it can still be a valuable claim. Okay, you can say chocolate over strawberry, and so we know what dessert to get you, for example. So it can be a legitimate claim. Okay. Well, it's been an hour and a half, which I think is probably more than enough. I've recently put out It from Qubit in 2 parts. That's well worth watching, I think. Such a great paper by David Deutsch, much less well known than his other things. This is the idea coming from It from Bit, which was Wheeler's idea, the great John Wheeler, who, when you read through his paper, which is not called It from Bit, it's called something else, but it puts forward that thesis, saying that physical stuff somehow comes from computation, that in a sense, all is information in a way. And he has this argument about, well, the surface of a black hole would contain only the information that has been lost in it, etc. The difficulty here is that physical stuff can always be understood at a deeper level. And so even if you think you've gotten down to these bits of information, you can ask why the world has the form that it does. And David's point is, and his great advance in It from Qubit, was to say, even if you were to assert that physical reality is made of information, guess what? The fundamental unit of information is the qubit, and the qubit is physical. So we return to physical reality is physical, which seems like a vacuous claim, but it's not when you've got idealists in the world. When you've got idealists in the world, people who say, we're all in a simulation, or it's all ideas, we're all imagining it. The latest instantiation of this is Donald Hoffman. He's getting a bit of a run at the moment, that we think reality into existence in some way, and that external reality doesn't have an objective existence. Well, he fails to grapple with what ideas are anyway. That ideas are a form of information, at least information processing. And information processing comes down to, fundamentally, the action of qubits. It can be reduced to what qubits can and can't do. And qubits are physical. They have to be a physical particle of some sort. Okay, so yeah, I would urge anyone watching this to watch that, especially if you're a fan of David Deutsch. It gives you a good insight into where he's coming from in terms of physics, epistemology, and computation. But for now, I think that will do me for the live stream. Yes, feel free to go to my channel, broader channel on YouTube, and to, of course, the podcast itself, and do become a Patreon if you feel so inclined. That's at bretthall.org. All links to there. Until next time, bye-bye.